Hello my dear young minds, welcome back. In our previous class, we discussed about some of the problems based on electric current, potential difference, resistance and resistivity. Today we are going to solve some of the other problems which are based on resistances connected in series and also resistances are connected in parallel. Right students, see I have written here some of the questions. Please try to understand the questions first. I am reading the questions, listen carefully. See students, here one circuit diagram is given. Here three resistors are there, R1, R2, R3. Three resistances given, right? And those three resistances are connected to a 6 volts battery. 6 volts battery, that is the question. See, so in this, from this diagram we need to calculate total resistance of the circuit. So how much resistance is present, total resistance in the circuit, and also total current flowing in the circuit. So we have to identify what is the total current present in this circuit, and also third one, the potential difference across R1. So three resistances are given. In that we need to find out potential difference across R1. See students, in the problem, right? See three resistances given, R1, R2, R3. See R1 is 7.2 ohms, R2 is 8 ohms, R3 is 12 ohms, and potential difference is 6 volts, right? So first we need to identify the total resistance in the circuit, and second one we need to identify the total current in the circuit, and the third case we need to identify the potential difference across R1. So what is the potential difference across R1? If you identify the diagram very clearly, so we can easily solve the problem. Students, here first we have to see all the resistances are connected in series or parallel. We need to identify. So it's not in all the three resistances are not in series, or all the three resistances are not in parallel. So that we need to identify. See students, here R2 and R3 are in parallel connection. Those two are parallel connection. Observe here, R1, R3 and R2 and R3 are in parallel connection. So we need to identify the equivalent resistance of R2 and R3. So first what we have to do, we have to find out the equivalent resistance of R2 and R3. See students, how to solve, we will see. R2 and R3 are in parallel connection. Based on the diagram, we observed that R2 and R3 are in parallel connection. So equivalent resistance. So 1 by R dash equivalent is equal to 1 by R2 plus 1 by R3. 1 by R2 plus 1 by R3. See students, 1 by R dash equivalent is equal to 1 by R2. R2 how much is given? 8 ohms. So 1 by 8 plus R3 how much is given? 12 ohms. So 1 by 12. Right? So equivalent resistance of 8 ohms and 12 ohms, because they are in parallel. So that 1 by R equivalent is equal to R2, 1 by R2 plus 1 by R3. So I have substituted the values of R2 and R3. So LCM between 8 and 12. 2 4 is 8, 2 6 is 2 2 is 2 3 is. So 3 2 is 6, 6 2 is 12, 12 2 is 24. So LCM is 24. So 1 by R dash equivalent is equal to 24 is the LCM. So 8 3 is 24, 3 into 1 3 plus 12 2 is 24, 2 into 1 2. So 3 plus 2. So 5 by 24. Right, 1 by R cube. So now R dash equivalent is equal to 1 by R cube is equal to 5 by 24. Now R dash equivalent is equal to 24 by 5. 24 by 5. So 5 4 are 20, 4.040, 5 8 are 40. So how much we got? 4.8 ohms. So equivalent resistance is 4.8 ohms. So we got equivalent resistance here, R2 and R3. So the equivalent resistance of R2 and R3 is 4.8 ohms. Now we will rewrite the circuit again. See, one resistance is R1, how much? 7.2 ohms. Now we got equivalent resistance here. How much? This is R dash. How much we got? 4.8. Now these two are connected to a 6 volts battery. Now we got the circuit diagram. Now if you observe R1 and R dash, those two are in series. We can clearly observe that these two are connected in series, end to end. So equivalent resistance in series, R equivalent is equal to R1 plus R dash. R1 is equal to, we know, 7.2 plus R dash is equal to 4.8. So 7.2 plus 4.8, 8 plus 2, 12. So 12 ohms. So finally total resistance is equal to total resistance. How much we got? 12 ohms. Total resistance is equal to 12 ohms. Students, in this circuit diagram, 3 ohms given, 2 ohms are connected in parallel. So that we have taken resultant resistance of R2 and R3. So we calculated. After that R1 and R dash are in series. So we got the total resistance. So we solved first one. Total resistance based on the diagram. Is it clear, students? Now, so second question, total current flowing in the circuit. What we need to identify? Total current flowing in the circuit. So now we need to identify the electric current is present. How much is present in the circuit? So students, we got the total resistance, and also here potential difference also given. Total potential difference is also given in the problem. So that students observe clearly from the diagram, given V is equal to, how much is given? 6 volts. Observe, 6 volts. And total resistance R is also we got from the above problem, 12 ohms. Now what is the electric current? I is equal to how much? That we need to identify. Right, students? So according to Ohm's law, V is equal to IR. V is equal to IR. So what we need to identify? I is equal to how much? So I is equal to V by R. I is equal to V by R. So I is equal to, we already we know 6 volts. Here we have written already 6, and total resistance also we know 12. 6 by 12. 6 1 ja, 6 2 ja. So 1 by 2. So 1 by 2 means I is equal to 0.5 ampere. Right, students? So we solved second one also. So total current, how much is present in the circuit? We got I is equal to 0.5 ampere, and total resistance which is present in the circuit, R is equal to 12 ohms. Now one more question is given. The potential difference across R1. Students, here we need to identify the potential difference across R1. How much potential difference is present across R1? See here, R1 is given. How much? R1 is equal to 7.2 ohms. So R we know. And also potential difference, how much is present? That we need to identify across R1. And also we know one more thing, electric current we know. So I we know and R1 we know. So we need to find out V. So students, here R is equal to how much? 7.2. And I is equal to, just now we got 0.5 ampere. Now what is V? What is potential difference across 7.2 ohms? That we need to identify. So same formula according to Ohm's law, V is equal to IR, right? Now V we need to identify. So V is equal to IR. V is equal to IR, right? Now I am substituting V is equal to I how much? 0.5 into R how much? 7.2. So we need to calculate 0.5 into 7.2. So 7.2 into 0.5. 5 2s are 10, 1, 5 7s are 35, 36. 0 2s are 0, 0 into 7, 0. 0, 6, 3. So how much? 0.2 points. So 3.6. How much we got? 3.6 volts. So potential difference V across R1, how much we got? V is equal to 3.6 volts. Is it clear? Students, don't get any worry. Whenever the problem is given, first we need to identify how many resistances are present in the circuit, how many are in that series and how many are in parallel. So first we need to, if the resistances are in parallel, first we need to identify the equivalent resistance between those parallel connection. After that, those two are in series connection. So we can easily solve the problem. Is it clear, students, what I explained? So first we need to study the circuit diagram. After studying the circuit diagram, we have to clearly see how many resistances are connected in parallel, how many are in series. So based on that, we will get the total resistance. After knowing total resistance, we know the total potential difference which is present in the circuit, and we can easily calculate the electric current. In the similar way, we will solve one more problem. We will solve one more problem. Students, see, now we are going to solve another problem. Here, question number 2. In the circuit diagram below, 5 resistance of 10 ohms, 40 ohms, 30 ohms, 20 ohms and 60 ohms are connected. So here 5 ohms are connected, right, to a 12 volts battery. 5 ohms are connected to a 12 volts battery. So what we need to identify? Calculate the total resistance in the circuit. Total resistance we need to calculate, and also total current flowing in the circuit, right? So observe the diagram. 5 resistances are connected. Here 10 ohms and 40 ohms are connected, and here 30 ohms, 20 ohms, 60 ohms are connected. 5 resistance are given. So observe very clearly, students. Here these 3 resistances are in parallel connection, and here if you observe, this 10 ohms and 40 ohms are also connected in parallel. So here these two resistances, for example, if you say R1, R2, here R3, R4, R5. Now see, observe, R1 and R2 are in parallel connection, and also R3, R4, R5, those 3 are also in parallel connection. So now we will find out the equivalent resistances, equivalent resistance of R1 and R2, and also we will find out the equivalent resistance of R3, R4, R5, right? So first we will find out the equivalent resistance of R1 and R2. So in this problem, see, observe, R1 and R2 are in parallel connection. Parallel connection. Equivalent resistance. So 1 by R dash. 1 by R dash equivalent resistance is equal to 1 by R1 plus 1 by R2. 1 by R1 plus 1 by R2. Now I am substituting the values. R1 is equal to 10 ohms. So 1 by 10 plus R2 is equal to 40 ohms. So 1 by 40. So 10 and 40, if you take LCM, you will get LCM is 40. 10 4 is 4 into 1 4 plus 41. So 1. So how much we got? 5 by 40. So 1 by r dash equivalent is equal to 5 by 40. Now r dash equivalent is equal to 40 by 5. 40 by 5. So 5 1 ja, 5 8 ja. So that is equal to 8 ohms. What we got? 8 ohms. So we got resultant resistance of R1 and R2. We got 8 ohms. In the similar way, we will observe R3, R4, R5 are also connected in parallel. So observe similarly R3, R4 and R5 are connected in parallel. So equivalent resistance. Again we need to find out equivalent resistance. So 1 by R double dash equivalent is equal to 1 by R3 plus 1 by R4 plus 1 by R5. 1 by R double dash equivalent is equal to 1 by R3 plus 1 by R4 plus 1 by R5. So now I am substituting the values of R3, R4 and R5. So R3, how much is given? 30 ohms. So 1 by 30 plus 1 by 20 plus 1 by 60. 1 by 30 plus 1 by 20 plus 1 by 60. If you take LCM for 30, 20 and 60, we will get 60 is the LCM. So 60 is the LCM. So 32 is so 2 into 1 2 plus 23 is 3 into 1 3 plus 1. So 2 plus 3 plus 1 is equal to 6 by 60. 6 by 60. 1 by R double dash equivalent. So R double dash equivalent is equal to 60 by 6. 6 1 ja, 6 10 ja. So that is equal to 10 ohms. Students, here we got equivalent resistance of R3, R4, R5, that is 10 ohms. Now students, here we got the equivalent resistance and here also we got the equivalent resistance. Now those two are in series connection. So the circuit diagram is like this. See, this is R dash and this is R double dash. So R dash, how much we got? 8 ohms. This is 8 ohms and here this is 10 ohms. So equivalent resistance, R equivalent in the circuit, potential difference is 12 volts. So R equivalent is equal to R dash plus R double dash, because these two are in series connection. So how much? 8 plus 10, that is equal to 18 ohms. So this is the total resistance present in the circuit. Right? So we have identified total resistance which is present in the circuit. How much we got? 18 ohms. Students, here in this problem given, 2 resistances are in parallel, another 3 resistors are in again parallel. So after here we have to find out the resultant resistance, and there also we need to identify the resultant resistance. Then those 2 resistances are in series connection, so that R equivalent is equal to R1 plus R2, we know, right? So we calculate. So we got the total resistance in the circuit. Now what we need to identify? Total current flowing in the circuit. So how much current is flowing in the circuit? So we need to identify electric current I is equal to how much. So students, in this problem we got total resistance and also potential difference is also given in the problem. So second solution for second one. So given given V is equal to 12 volts, and also total resistance we got 18 ohms, and what is electric current? I is equal to how much? So students, according to Ohm's rule, V is equal to IR. I is equal to V by R. I is equal to V by R. So now I am substituting V value and R value. So that is equal to V is equal to 12 volts by R is equal to 18. Right? So 2 6 is 2 9 is 3 2 is 3 3 is. So how much we got? 2 by 3. How much we got? 2 by 3. If you divide 2 with 3, how much we will get? 0. When we put 0, 20, 3 6 is so 0.6. Again 0.6, again 6. So 0.7. So current I. So amperes. So I is equal to total current in the circuit 0.67 amperes. In total resistance we got 18 ohms. So R is equal to 18 ohms. Total resistance in the circuit 18 ohms. Total current in the circuit is 0.67 amperes. 0.67 amperes. Observe students what I said. Understand. See here you have to study the circuit diagram very carefully. If you study the circuit diagram carefully, you can easily solve the problem. Understand what I said? Right. And one more problem students, you please try yourself. Here a radio set of 60 watts runs for 50 hours. How much electrical energy consumed? Students, once again I am reading the question. A radio set of 60 watts runs for 50 hours. How much electrical energy consumed? So how much electrical energy consumed by the radio set? Here the usual power is given. How much? 60 watts, and also time, how much time is utilized, the radio set, that is also given. So time is given and power also given. You need to calculate the electrical energy, how much electrical energy consumed. Right students? See in this problem, see observe solution 3. Students, very easy. Given power is equal to 60 watts, and also time is given, T is equal to 50 hours, and how much electrical energy consumed by the device, E, how much energy is consumed by the device, that we need to calculate. Students, here whenever we calculate electrical energy consumed by the device, right, so always we use the commercial unit for electrical energy is kilowatt hour. So kilowatt hour is the commercial unit for electrical energy. So here students, power is given in watts, so that power you have to convert into kilowatts. You please don't forget this. Always we need to convert the watts into kilowatts. In the problem, if they are given directly kilowatt, no need to convert. Right? Here power is given watts, so we have to convert this watts into kilowatts. So how can convert? By dividing with 1000. So it is converting 60 by 1000 kilowatt. 60 by 1000 means how much? 0.06 kilowatt. 0.06 kilowatt. So power we converted watts into kilowatts. How much we got? 0.06 kilowatt. Time is anyhow it is given in hours, so 50 hours. Now we know formula, electric power P is equal to electrical energy consumed by the device by time. So what we, from this formula, cross multiplication, W is equal to, that implies electrical energy consumed by the devices is equal to power into time. So power how much? 0.06 into time 50 hours. So we will get the answer. So nearly how much? 0.06 into 50. So 3 kilowatt hour. 3 kilowatt hour. How much energy consumed by the radio set? 3 kilowatt hour. 3 kilowatt hour. This kilowatt hour is the commercial unit of electrical energy. 3 kilowatt hour. So 3 kilowatt hour is consumed by the radio set. Students, in the same way you can easily calculate whatever the appliances are working in the house. One by one device we can calculate, and if we add, we will get the total energy consumed by the all the electrical appliances. Students, whenever the power is given, you please convert, means power if they given in watts, you have to convert into kilowatts. If time is given in seconds, you please convert into hours. And electrical energy consumed by the each device, so E is equal to power into time. If you calculate, you will get the kilowatt hours, how much kilowatt hours they consumed. Generally this kilowatt hour is called 1 unit, what we call 1 unit. So the TV set is consuming 3 units. If the 50 hours for 1 month means it is consuming 3 units for every month. 3 units consuming by the radio set for every month. So that unit rate also sometimes they give in the examination. So 1 unit rate is nearly 3 rupees or 4 rupees. So 3 into 4 rupees means 3 into 4. 3 4 is 12 rupees. So we need to pay 12 rupees per radio set for every month in our current bill. In the same way, all the electrical appliances, how many we are utilizing. So if you know the watts, how many watts and how many hours we are using. So if you calculate electrical energy consumed by the devices, each and every device, okay, so from based on this we can easily add all the appliances, we will get the electrical energy. Based on that, how much units we are consuming, we can come to know, and also we can calculate our electricity bill also. Right students, see, yesterday we discussed, means our previous class we discussed some problems, and today we are also discussed about 3 problems. These are based on the resistances and electric power. So these are the simple problems, these are the some simple problems. So if you understand these basic problems, we can come to know some other difficult problems, and we can easily solve those problems. So students, once if you practice these problems, you will understand. Without practice, just if you listen also, again you will forget. So you please refer the books, and whatever the problems based on the formulas, you please solve. Then you will get lot of doubts. I will clarify all the doubts, right? And again in our next class also we are going to solve some other little bit difficult problems. Is it clear students? So I hope that all the students will practice the problems, and also almost we have completed the chapter, right? So based on this chapter, and also we completed chemistry also 1 chapter, and based on both the chapters you are going to write a test, maybe next class or the next class. So once if you practice, if you feel I understood very well, means I am going to conduct test, right? So please students, read all the theoretical concepts and also practice the problems. You have any doubt, you please ask me, again I will tell you. Okay students, stay home, stay safe. Thank you.